Welcome back, grade 10s. This is remote video lesson 8, and I'm going to discuss the gases and gas volumes again. I find it easier to work with the volumes of gases because of Avogadros Law. The volume ratios would be exactly the same as the mole ratios given by the balanced equations. So I just first of all want to whiz through volume conversions. I want to start with the units that we measure length or distance. 1 meter will contain 10 decimeters, and it will contain 100 centimeters and 1,000 millimeters. If we work from length, the unit for length, to the unit for the area would be represented by a square meter, square decimeter, square centimeter, and square millimeter. 1 square meter will have 100 square decimeters, which will have sorry, I made a mistake there with the centimeters, 100 centimeters, which will have 10,000 square centimeters and 1,000,000 square millimeters. The next conversion is the units to volume. So volume is measured in a cubic meter, cubic decimeter, cubic centimeters, and cubic millimeters. So a volume, 1 cubic meter would be equal to 1,000 cubic decimeter, which will be equal to 1,000,000 cubic centimeters and 1,000 million cubic millimeters. Now, the important volume conversions would be from a cubic meter, from a cubic decimeter to a cubic meter. You'll have to divide by 1,000. From 1 cubic decimeter, you will, if you have 1 cubic decimeter, you'll have 1,000 cubic centimeters. So the conversion from cubic centimeters to cubic decimeters, you need to divide by 1,000 again. These are the 2 very important conversions. Then another thing that we need to know is that a cubic decimeter is the same as 1 liter. And we need to know that a cubic centimeter is the same as a milliliter. Right, let's move on to the real stuff. So the conditions that affect the volumes of gases are the following: pressure, a fixed volume, and temperature. If you increase the pressure on a gas, the volume will go down. If you increase the temperature of the gas, the volume will go up. The hotter it is, the more it moves around, so it will expand. So scientists had to define a standard temperature and pressure, which is the following. The STP means standard temperature and pressure. Standard temperature is 0 degrees Celsius, or as I've introduced in class, 273 Kelvin. And standard pressure is atmospheric pressure, or 1 atmosphere, it's 101.3 kilopascals. Molar volume is the next topic, and it is the volume of 1 mole of a gas at standard temperature. So we use the molar volumes when all the reagents are gases, and reagents, just to explain what reagents are, they are the reactants and the products mentioned together. What is the molar volume at STP? It is 22.4 cubic decimeter with the symbol Vm. How do we calculate moles and volumes from molar volume? This is the equation. The number of moles, N, would be equal to the volume of the sample of gas divided by the molar volume. This we use when we work with under standard temperature and pressure conditions. Avogadros law we've discussed in class. Equal volumes of gases at the same temperature and pressure will contain the same number of molecules. So if I have 1 mole of hydrogen at STP, its volume will be 22.4 cubic decimeters, and you see they're using liters in this, and you'll have Avogadros number of particles, 6.02, 10 to the 23 molecules. The same for the oxygen and the carbon dioxide. Let's do our first examples. Determine the volume of the following gases at STP. You've got 2.4 times 10 to the 5 molecules of nitrogen. Now the problem here, to determine volume, I need to use the equation N mole equals V over Vm. So the volume of the gas would be the moles of the gas times the molar volume of the gas. And if we have the number of particles, so this is the number of molecules, we need to calculate the moles first. So the mole of nitrogen would be the number of molecules divided by Avogadros number. So this would be 2.4 times 10 to the 25 divided by 6,022 times 10 to the 23. Let's do this calculation. 2.4, 10 to the 25 divided by 6.022, 10 to the 23, and I get 39.85 mole. Now I've got enough information to calculate the volume of the nitrogen. It's the 39.85 mole times the molar volume at STP, which is 22.4. 39.85 times 22.4 gives us a volume of 892.64 cubic decimeters. Like I've advised before, you are welcome to pause the video in order to do the calculation. The next one we need to do is we need to calculate the volume of 0.5 mole oxygen. In this question, they've given us the moles. So it's very easy. The moles would be equal to volume over molar volume. Moles is 0.5. Volume, we don't know. Molar volume is 22.4. So volume would be half of 22.4, which is 11.2 cubic decimeter. The next one, they give us 4 grams of carbon dioxide and they want us to calculate the volume of the carbon dioxide. Now we know that whatever they give us, we need to convert it to moles first. So it's the mass of the carbon dioxide divided by the molar mass. So it's 4 grams, and carbon dioxide is 12 for carbon and 32 for the 2 oxygens. So that is 4 divided by 44, which equals 0.091, 0.091 moles of carbon dioxide. So the volume would be the moles times molar volume, which is 0.091 times 22.4 at STP times 22.4. That gives us 20.36 cubic decimeter. I think there is one more of these calculations. Right, we're going to go to the next level where we determine the following amounts of gases at STP. And I think the question has 3 or 4 different ways of asking it. The first one is that we need to calculate the moles of 10 cubic decimeters molecules nitrogen dioxide. So to do this, moles from volume is V divided by Vm at standard temperature and pressure. So it's 10 divided by 22.4. 10 divided by 22.4 is 0.446. 0.446 moles of nitrogen dioxide. The next one asks us to calculate the mass of 30 cubic centimeters of sulfur trioxide. Whatever they give us, we need to turn it into moles. So the moles would be volume divided by molar volume. Now, the problem here is the cubic centimeters. I've got 30 cubic centimeters. How many cubic decimeters are there in there? We need to divide by 1,000 to change cubic centimeters to cubic decimeters. So it's 0.03 cubic decimeters. So 0.03 cubic decimeters divided by 22.4 cubic decimeters. The units must be the same. 0.03 divided by 22.4 is 0.0134. I'm going to write it in scientific notation, 1.34 times 10 to the minus 3 moles. And they want the mass. They want us to calculate the mass. If we've got the moles, mass is easy to calculate. It's the moles times the molar mass. Now, for the molar mass, we need to write down the formula of the sulfur trioxide and then calculate its molar mass. It's 1.34, 10 to the minus 3. And the molar mass, sulfur, it has a mass of 32 plus 3 times 16 for the oxygens. Multiply this answer by 32 plus 3 times 60, and we get 0.107 grams. Right? Pause whenever you need to. Right. Number of molecules in 15 cubic centimeters of carbon dioxide is the next question. Right, so whatever they give us, 15 cubic centimeters, needs to be converted to the mole. But before we convert it to the mole, we need to convert it to cubic decimeters. So the moles of the gas would be the volume divided by the molar volume, which is 0.015 divided by 22.4 4 sure. So this is 6.696 times 10 to the minus 4 moles. And the number of particles would be the moles times Avogadros number, which is 6.696 times 10 to the negative 4 times the 6.022 times 10 to the 23. And that gives us 4.03 times 10 to the 20 molecules. Right. I'm stopping. This is the next video.